Hello everyone, I am Radha Kumari Pani, Assistant Professor at Vedang Institute of Technology. So let's start the fresh and fresh series that is about BTech chemistry. All the module that are 5 modules is there as per the new BPUT syllabus. So we'll cover up all MCQ type question. This will be added to the extra knowledge, okay? And also it will be quick revision what we are going to study for all the modules. The first module is your periodic properties. So let's start. First module, periodic properties and the MCQ type. The first question is, which of the following orbital experience the highest penetrations towards the nucleus? Okay, first of all, what is penetration? Penetration means it is the shielding of orbital, okay, towards the nucleus. That means, as we all know, there are 4 orbitals are there, sp, df, and according to their shape, the penetration power is different for all the orbitals, and the general trend for the penetration power for all the orbital s will be more than that of 3 orbital. Why? Because as we know, the s is spherical shape and p is dumbbell shape and d is double dumbbell, f is complicated or diffuse shape. So the penetration power of s will be more than pdf. Why? Because it is the circular shape, the highly penetration it will be than that of diffuse shape of orbital. So it is easier to cancel out those 3 p orbital. Okay, the rest is 2s and 3s. Now from the 2s and 3s, the which orbital the penetration will be more? 2s orbital will be more. Why? Because 2s is nearer to the nucleus, because it is in second period. 2s means second period. The cell number is 2. Here it is the cell number. Okay, here it is cell number is 3. The 2s will be more closer towards the nucleus. That's why the 2s, the penetration power of 2s will be more. Okay, it is easier, first cancel out all, eliminate all the least probable option, then it will be easier. Okay, now the second question is, effective nuclear charge for 2p electrons is lowest. Now what is effective nuclear charge? Effective nuclear charge means it is the net effect of nucleus on the valence shell electron. So as the general trend, we know the effective nuclear charge along the period increases from left to right. Why? Because if you are going from left to right, the one extra electron is added up to the extra cell. Okay, as you are going to lithium, it is in lithium, then beryllium, boron, carbon. It is in second period, also it is in series of along the period, goes on increasing. So if you are going from lithium to beryllium, boron, carbon, it is in first group, beryllium second group, and boron group number 13, carbon group number 14. Also we know the electronic configuration, it is that is 2s1 beryllium, 2s2, this is 2s2, 2p1, 2s2, 2p2. Okay, so the extra cell electron in the outermost cell goes on increasing, so effective nuclear charge also increasing, because if it goes on increasing, the number of extra proton will be added up, so the effective nuclear charge on the valence electron will be more. So the least will be in case of lithium. It is the general trend. Okay, it is easier question because the effective nuclear charge increasing along the period, so lithium will be least one. Now the third question, the shielding effect is least for the electron. Now what is shielding effect, or also we can say it screening effect. Shielding or screening means what? Normal English. Screening or shielding means it is the screening or middle part of nucleus and valence shell electron. Okay, the valence shell electron, let's suppose atom is there, it is the nucleus and it is the valence shell electron. The orbital are shielded between the nucleus and electron. Okay, so the shielding power will be more in case of s. Okay, the shielding power will be more in case of s. Why? Why in the case of s shielding power will be more? Because it is more closer to the nucleus. So the screening or shielding effect will be more, and also it is in circle shape. Okay, spherical shape. But in case of PDF, the more diffuse it is shape, the less shielding will be happen. So the shielding effect is least for f orbital. Okay, also the shielding effect or screening effect also we can calculate by the Slater's formula. One is there. We can calculate the effective nuclear charge, atomic number minus shielding constant. Okay, by in that equation also. But remember, the shielding effect trend for the orbital is s is more than p, then d, then f, according to their shape. Now the fourth one. The energy of orbitals in the multi-electron atoms increases in the order C. If we are going to tell the arrange the orbital according to their energy, okay, then we'll go S, then P, then D, then F according to their cells. But here for the multi-electron atom, one rule is there, above principle, that is N plus L rule. Okay, the N plus L rule, the orbital's energy will be goes on increasing by N plus L rule. So now 1s n, if you are going to follow the N plus L rule, 2s 2p, 3s 3p, 4s 3d. Here A will be the correct option. Why? Because here it in case of 3p, the N plus C, the 2s and 2p will be more, because N plus L for N2 P1 it will be 3. Okay, and here it is N plus L is 3. Here also for 3p N plus L will be 4, 4s will be 4, and 3d will be 5. So as per N plus L rule, the orbital energy will be like this. Why not these three option? You can we can see 2s and 3s. After after 2s 2p will be there. Why? Because here the N plus L is 2. Okay, here the N plus L is 3. Here also the N plus L is 3. But we know if the N plus L rule is same, N plus L value is same for the two orbital, the orbital which have less N number, that will be filled past. Okay, why? What does that mean? Means if we are comparing between 2p and 3s, the 2p the cell value is 2 and the 3s cell value is 3. The 2p will be filled fast than 3s. So it will cancel out. Next, 1s 2p, here it will also cancel out because here 2p value is 3, here 2s value is 2. So here also. Now the third one, 1s 2s 2p, here mistake, first 3s then 3p. So the correct option will be option number A. Now fifth question, which element has the highest effective nuclear charge in period 2? Same general trend, effective nuclear charge goes on increasing along the period from left to right. Why? Because if you are increasing from left to right, one extra proton will be added up in the nucleus. So the net effect on the valence electron will be increasing. So the highest effective nuclear charge in the period 2 will be fluorine, because along the period the fluorine will be in group 17. Lithium group 1, beryllium group 2, nitrogen it will be in group 15, fluorine is group 17. So fluorine will be highest. Then atomic radius decreases across a period. Reason, atomic radius decreases across a period. Why? Same concept, effective nuclear charge. If you are going to increase the effective nuclear charge, so the attraction of nucleus on the valence electron will be increased. If the attraction will be increased, so the atoms will be shrink towards the nucleus. So the radius will automatically decrease. So the reason is effective nuclear charge increases. Simple concept. Here, this type of concept, question also is useful for your competitive exam point of view. Also, there will be quick revision for BTech chemistry. Now, the seventh question, at ionic radius of O2 minus is larger than F minus. Why? The reason why. See, in case of ion, we'll see if the formal charge or the charge is more, O2 minus the charge is more, then there will be repulsion of electron, there will be repulsion. So automatically there will be increase in size. But the reason is effective nuclear charge. Okay, the main concept is effective nuclear charge. Oxygen is in group what? 16, and fluorine is in group 16. Group 16 oxygen is there, group 17 fluorine is there. So the effective nuclear charge is increasing along the period. So effective nuclear charge on oxygen will be less. So the ionic radius will be more. Okay, effective nuclear charge and atomic radius, effective nuclear charge and atomic radius inversely proportional. If is more, atomic radius will be less. Simple. Now, the question number 8, the element with lowest fast ionization energy in period 3. This in period 3, okay, sodium, magnesium, aluminium, chlorine. These all elements are in period 3. Okay, the question is about lowest fast ionization energy. What is fast ionization energy? See, ionization energy is the energy required for the releasing of electron from outermost orbital. Okay, the energy, simple, the ionization energy is the energy required for the releasing of valence shell electron from the atom. Now, if we are going to see it electronic configuration for sodium, for magnesium, for aluminium, for chlorine. Sodium, it will be 3s1. See, I am writing the only the valence shell electronic configuration. Okay, don't confuse in that. Magnesium, it will be 3s2, and aluminium will be 3s2, 3p1, and chlorine will be 3s2, 3p5. Okay, so what happens? 3s1, 3s2, 3p1, 3p5. The fast ionization energy list, that will be easy to removing the outermost electron. That will be in case of sodium, because if the outermost, it release the outermost electron from 3s orbital, then it will acquire the inert shell gas configuration, that is neon. Okay, the main, if you know the general trend, that's okay. The fast ionization energy, the general trend will be along the period will be increasing. Okay, because the atomic radius goes on decreasing, so the ionization energy also goes on decreasing, because it is difficult to release the outermost electron from the lesser size of atom. Okay, but the main concept will be the sodium, the ionization energy will be least, because it is more easier to release the outermost shell electron. By releasing the outermost shell electron, it will acquire the neon, that is inert shell configuration. So for the least in case of sodium. Okay. Now the question number 9. Fast ionization energy generally increases across a period. Last question also I have told, because the increasing in effective decrease in nuclear size, no. Okay, because the increase in effective nuclear size, yes, along the period the effective nuclear size decreases. Increase in atomic size, no, because along the period atomic size goes on decreasing. Now the decrease in shielding, no. Increasing shielding, because the one outermost electron, if you are increasing, the shielding also increasing. The correct option will be increase in effective nuclear charge. Now the question number 10. Which of the following has highest electron affinity? First, what is electron affinity? Electron affinity, same. It is the vice versa of ionization energy. Electron affinity means it is the net electron gain energy that is required for the atom when it will attract one electron. Okay, ionization energy is the energy that is required for the releasing of electron. Electron affinity, the energy required for attraction of one electron to the valence shell. So, which case it is will be highest electron affinity, means highest energy required for attraction of one electron. Nitrogen, oxygen, fluorine, chlorine. Nitrogen, the electronic configuration, if we will draw 2p3, oxygen, it will be 2p6, fluorine 2p5, and chlorine also will be chlorine will be 3p, electron outermost shell configuration 3p5. Okay, so in which case has the highest electron affinity, means highest energy is required. C. The smaller size will be in case of this will be bigger in size. Okay, so in case of oxygen 2p3 highest electron affinity. Okay, this will be the correct option will be nitrogen. Why? Because see, nitrogen is here 2p3 means it is the highest stability, because we know that least half that is sorry, this is completely half filled orbital. Okay, half filled orbital of 2p that add up the most stability to the nitrogen. So it will not easy to attract one electron to the valence shell electron. Why it will be add up? Because the nitrogen is more stable in its configuration, one configuration. Why it will be attract the one electron? So the nitrogen will acquire more energy for the attraction of one electron. The nitrogen will be correct answer. Now the question number 11. Electronegativity generally. General trend, the electronegativity increases along the period, decreases down the group. Why? Electronegativity means, what is electronegativity? Electronegativity is the power, is the ability of an atoms to attract the electron pair towards itself. Okay, so along the period, effective nuclear charge increases, so the electronegativity also increases. And down the group, what happens? Down the group, electronegativity decreases because the atomic radius increases down the group, so the electronegativity also decreases down the group. Now the question number 12, the most electronegativity element. Now we know the general trend, the electronegativity is increased along the period. Why? Because along the period effective nuclear charge increases, so the attraction power of the bonded electron towards itself will be more. So along the period, chlorine, oxygen, fluorine and nitrogen. Here the fluorine will be in group 17, nitrogen is here, oxygen is here, chlorine second element of group 17. Okay, and also the electronegativity power decreases along the period, so fluorine will be highest, and the electronegativity value is approximately 4. Now polarizability is maximum. What is polarizability? Polarizability mainly it is according to their size of the anions. Okay, greater the size, greater will be the polarizability. Polarizability means the capability of acquiring the electron in its outermost shell. Okay, the highest the size, more will be the polarizability. So the polarizability maximum in case of iodine minus, because along if we are going down the group, fluorine, chlorine, bromine, iodine will be more in size, so the polarizability power of iodine will be more. Generally polarizability is directly proportional to the size. Okay, now an element with electronic configuration neon 3s2 3p5 will show maximum oxidation state of, first of all, neon 3s2 3p5 means 10 12 17. This is 17 means the electronic configuration of chlorine atom. Okay, we know that the chlorine atom general oxidation state, it will show -1. Okay, why? Because if we'll acquire one, if it is the nearest to the electronic configuration of argon, if we acquire one electron, then will be nearest configuration of argon, that is neon 3s2 3p6. So the maximum oxidation, it will be -1. Which pair of ions is isoelectronic? Isoelectronic means the atoms having same number of electrons. Okay, first pair is sodium plus magnesium plus 2. Sodium 11 plus means 10, magnesium 12 plus 2 means 10. Option Y. Option A will be answer, because in second B, C, D, B it will be 10 and aluminium 3 plus 13, 10. Sodium also will be 10 and aluminium 3 plus will be also 13, 10. Fluorine will be 10 and chlorine will be 18. Magnesium 10 and fluorine. Which pair of ions? Sorry. Here option A, option B and option D. 3 are correct, because in the case of sodium plus, aluminium plus also having same number of electron, magnesium 2 plus and fluorine also having same number of electron, 10, 10, 10, and this pair is different. Okay, multiple choice question. Now, which of the following has the highest ionic size? Remember, highest ionic size, if we are going to increase the first general trend atomic radius, we know along the period it is decreases, but if in case of anion, in case of ions, okay, in whether it may be cation or anion, the ionic size will be according to their charge. If you are acquiring the minus charge, it will be highest ionic size, because minus charge means it has accept one electron in the outermost shell, so there will be repulsion between, because the fluorine is a small size. Okay, second it is in second period, so if you acquire the one electron, there will be repulsion between electrons and electron, so this will be adapted new ionic size. So the ionic size will be more in case of fluorine. Now the question number 17, that is, which of the following order of first ionization energy is correct? Okay, Same, ionization energy is the energy required to releasing outermost shell electron. So the general trend will be, see, ionization energy along the period increases because the atomic radius decreases. So it will be more difficult if you are going to release one outermost electron from the smaller radius. So it will be more difficult than the bigger radius. So the general trend for the ionization energy will be high, along the period increased. So sodium, magnesium, aluminum. These elements are in the third third cell, that is sodium. Here it will be after lithium, sodium, magnesium, and aluminum. Okay, it is in the increasing order of third cell. So the general trend will be the ionization energy will be increased. Sorry, it is in decreasing order. So the general trend will be increase along the period because sodium, magnesium, aluminum in the third period. Okay, because the outermost cell, if you are going to its right outermost electrons, for sodium will be 3s1 and for magnesium 3s2 and for aluminum 3s2 3p3. Okay, so the increasing order will be this. So it is in option number B. Aluminum will be highest, then magnesium, then least one will be sodium. General trend. Now the question number 18. Electron affinity is lowest in which case? Electron affinity means the net energy required for acquiring one electron, for attracting one electron towards the atom. So first eliminate the option number D, neon. Why? Because neon is the inert gas configuration. So the electron affinity will be more, will be highest because itself is it is in stable orbital inert shell configuration. Okay, so the electron affinity will be highest. Why? It will be add up the one electron if it is in stable configuration. So now chlorine, oxygen and fluorine. See, oxygen is 2s2 2p4, fluorine will be 2s2 2p5 and chlorine is the third cell, that is 3p5. So the general trend same as in the ionization energy, electron affinity along the period increases and down the group decreases because down the group the atomic radius will be more. So it is easier to acquire one electron towards the outermost cell. So the least will be chlorine, then oxygen, then fluorine. Option A will be right answer. Now the oxidation state of halogen generally varies between -1 to +1, -1 to +7, 0 to +4, never, because we know that halogen will always show the -1. Okay, -1 to +1 generally varies. That will be, see, if you are going to write the outermost electronic configuration of halogen, what will be? For the fluorine, chlorine and bromine, it is like this: NS2 NP5, general electronic configuration for the halogen. Okay, so if it is added one electron, then it will be -1. If we'll remove all the 7 electron, so it will be +7. Okay, -1 to +7 will be answer. Now the last question 20. Which of the following has highest polarizing power? So to determine the polarizing power, we have the formula, that is polarizing power is directly proportional to the charge and inversely proportional to the size. Okay, so the charge in this 4 option, aluminum 3+ has the highest charge. The smaller the radius, smaller the atom, the polarizing power will be more. Okay, don't confuse between polarizing power and polarizability. Polarizability means maximum ionic radius. Okay, and polarizing power means high, the smaller the size, greater the charge, polarizing power will be more. So behind this option 4 option, C will be higher because aluminum 3+, the charge is more in case of aluminum. So up to this, so we'll gonna continue this all type of multiple choice question. So today's class up to this much. Let's wind up. here. So in next classes, we'll refresh the another phrase 20 multiple choice question, either in from this module or in any different modules. Okay. So thank you so much. Have a nice day.